NASA appears to be moving full speed ahead with its plans to establish a long-term human presence on the Moon. Just a couple of months after its ignition event in March 2026, the agency has revealed one of the key pieces of equipment that Artemis astronauts will rely on during future lunar missions: the vehicles that will transport people and cargo across the Moon's rugged surface. For a long time, NASA was expected to choose a single rover design from 3 competing teams led by Astrolab, Lunar Outpost, and Intuitive Machines. But after the ignition event, it became clear that the agency was shifting towards smaller and more flexible vehicles. In the end, NASA selected 2 lunar terrain vehicles, or LTVAs. One is the Pegasus rover from Lunar Outpost, and the other is the crewed lunar vehicle, known as the CLV-1, developed by Astrolab. Today, we're taking a closer look at the CLV-1, which evolved from Astrolab's earlier Flex rover concept. While many of the original ideas remain intact, the final vehicle includes several important updates designed specifically for NASA's latest lunar exploration plans. One of the biggest new details is the rover's size. While packed inside Blue Origin's Blue Moon, Mark 1 lunar lander, the CLV-1 measures about 2 meters long, 2.3 meters wide, and 2.2 meters tall. Once it reaches the Moon and deploys its solar panels and communications antenna, it expands significantly, stretching to around 4 meters in length and standing about 2.6 meters tall. The rover will weigh roughly 950 kilograms on Earth and is designed to travel across the Moon at speeds of up to 10 kilometers per hour. That's slower than the original Flex concept, which was expected to reach twice that speed. But the focus now appears to be on reliability and mission support rather than outright performance. One of the most interesting features is its wheel technology. The CLV-1 uses Astrolab's deformable wheel design, developed specifically to handle the Moon's harsh terrain. These wheels are built to absorb bumps, maintain traction on steep slopes, and operate in temperatures ranging from an icy minus 240 degrees Celsius to a scorching 130 degrees Celsius. Earlier versions of the design use 192 cable-like structures acting as both spokes and springs, creating a flexible wheel capable of handling extreme conditions. NASA requires the rover to carry 2 fully suited astronauts, along with at least 500 kilograms of additional cargo. Beyond that, Astrolab has not revealed many details about the vehicle's cargo systems. Earlier Flex concepts included a robotic arm for moving equipment, but it remains unclear whether that feature made it into the final CLV-1 design. The rover is also designed with flexibility in mind. Astronauts can drive it directly during lunar missions, but it can also be operated remotely. That capability could prove especially valuable during the Moon's long nights, which can last for roughly 2 weeks at a time. Astrolab isn't building the CLV-1 alone. The company is working alongside Axiom Space, which is supplying the Artemis moonwalking suits, as well as Interlune and Odyssey Space Research. Together, the team has secured a NASA contract worth $219 million to bring the project to life. Looking beyond Artemis, Astrolab has even bigger ambitions. The company hopes to turn the CLV platform into an entire family of extraterrestrial vehicles. Future versions could support commercial lunar operations and international missions, including the Mona Luna rover that is expected to fly for the European Space Agency around 2030. Of course, the CLV-1 is only one of NASA's 2 winning rover designs. Lunar Outpost's Pegasus rover was also selected and offers similar capabilities. We'll have to wait a little longer to see how the 2 vehicles compare in detail. And there's also the story of the rover that didn't make the cut, Intuitive Machines' Racer concept, which was left out despite being one of the original contenders. As NASA continues laying the groundwork for a permanent return to the Moon, these new lunar vehicles could become some of the most important machines ever built for exploring another world.